Hello, Algebra 2 students. We're going to go over section 4.4, complex numbers. We can perform operations with pure imaginary numbers, and then we can equate complex numbers, which actually we might save this for in class or another video. So we're going to talk about complex numbers, and to talk about complex numbers, we got to talk about the imaginary numbers. And when I think of imaginary numbers, I think of SpongeBob and his imagination. So that's what we're going to be doing. We're going to be using our imagination and looking at the imaginary number I. So what is I? I is the square root of a -1. That is what I is. So with that said, then I squared, what would I squared be? Get rid of this here, it would be a -1. So knowing that I is the square root of a -1 and I squared equals a -1. Here are some examples of imaginary numbers. For example, 6i, -2i, I times the square root of 3. Those are just some examples of imaginary numbers. And we'll get into complex numbers, not in this video, but either another video or in class. So if we want to simplify square roots, we have to remember how to do that using perfect squares, and now we're going to be using I. So I'm going to look at the square root of a -27 first. So how I like to do these, and you guys probably remember this from geometry, is I kind of like to make a factor tree, but with perfect squares. So a perfect square that goes into 27 is going to be 9. And I also see this negative here, so I'm going to factor out a -1. The 9, which is the perfect square, and then what's left over? 3. So the square root of a -1 is going to be my I. The square root of 9 is 3, so that comes on the outside. And we just put the 3 before the I, the numbers before the I. And then the square root of 3, is that perfect at all? No, so we're just going to leave it as 3i square roots of 3. And that would be our answer for that one. What about the square root of a -216? Let's think about a perfect square that goes into 216. We know we're going to have -1 because we have this negative here. Can you think of a perfect square that goes into 216? 36. Very good. And 36 times 6. So the square root of a -1 is I. Square root of 36, that's perfect, so we can bring that out front. And then we have the square root of 6. And that is simplified. You always want non-perfects inside your square roots. Okay, so let's go over the powers of I. So here is a list of I to certain powers, and they're all simplified here, and I go up to 8. So you might want to write this down in your notes just to have it. So for example, if I were to say, what is I to the 15th power? You'd be able to look at this and say, okay, well, 15 I can split up into I to the 5th times I to the 5th times I to the 5th. Because remember with exponents, when you're multiplying the same base, you add the exponents. So what is I to the 5th? It ends up being I in this chart. So I times I times I. Well, I times I, which is I squared, is going to be a -1. And then we're left with I here. So I to the 15th power is going to be a -I. So that's some simplifying using the powers of I. I just think that sounds so powerful. Powers of I. All right, the next one, next example would be simplifying imaginary numbers. Oh, this is one of my favorite SpongeBob episodes, the Bubbles one. Bring it around town. Love that one. Cracks me up. So with this, where you can go ahead and look at your numbers or your coefficients on I. So negative 5 times 3 is a negative 15. And then we have I times I, which is I squared. And remember what I squared is it is a negative 1, so we have a negative 15 times a negative 1. Ends up being, our final answer is 15. So that's how we simplify just imaginary numbers. Now what about this one? We know if we simplify this, we have a negative inside the square root, so that's going to come out in front as an I. We can't split this up at all because there's no perfect squares that go into 6. Same thing here, we're going to bring out the I. And we can't split up 15 at all because it's not a perfect square. But we can combine radicals, these square roots. So we have I times I, which is I squared. And we have 6 times 15, which is 90. Now 90, can we split that up? Of course. It's 9 and 10. And I squared is negative 1. So if we split up as 9 and 10, the square root of 9 is 3, so 3 times negative 1 is going to be a negative 3. So a negative 3 square root of 10 is our final answer. Alright, another type of problem that we're going to have is solving equations with imaginary numbers. So we're going to subtract 64 from both sides. And again, this is using the square root property where we just have an x squared and we can solve this. Alright, sorry about that, Mr. Edgerly popped in. So we have negative 64, so now to get rid of the square, we're going to square root both sides. And the square root of 64, again, we have this negative 1 here, so that's going to be the I that comes out. And the square root of 64 is perfect, and it's 8. But now remember, when we're solving equations here, it's going to be plus or minus 8i. Alrighty, so pause the video, see if you can do this one. Alright, let's see if you get the same thing I do. I'm going to subtract 100 from both sides. And then we divide by 4. And now we can square root. Again, we have a negative inside the square root, so that's going to be an I. And we have x equals plus or minus 5i because 25 is perfect. Very good. I'm guessing some of you are asking, well, what if it's not perfect? If it's not perfect, let's say you got an answer like the square root of 13, negative 13. You bring the I out in front here, leave it in here, and then plus or minus right here. So that's if it's not perfect. You still bring the I out, keep it positive inside. Alright, that's just half this section. So come with questions. That's all I have. And we'll finish the other one up in class, most likely. Alrighty? Alright, we'll see you guys later.